stem and leaf plot, your data is organized into two pieces separated by a line. Okay? Stem usually represents tens. And then your leaves on the right usually represent ones. Okay? And the way that a stem and leaf plot is read is each of the leaves represents one piece of data. Okay? Each leaf represents one piece of data. Okay? Now, what do I mean by that? There are right now 2, 4, 6, 8, 10, 12, 14, 15 leaves. Okay? That means that we are looking at the amount of time that 15 different students spend on task. Or we could be looking at one student over time, over a 15-day period, how much time did they spend on task, right? But we're looking at 15 individual pieces of information. All right? And the way that we read the information is stem and then leaf. So if I wanted to write out all of the values that are in this chart in a list, it would look like this. 90. All right, 90 is 90. The next zero over there doesn't mean 900. Again, we go stem and then leaf, individual leaf. So another 90. So there's 2 times or 2 students that are on task for 90 minutes. And then moving down, 87, 86, 84, and so on, all the way down until 41. Okay? So it would be 15 different values, how much time is spent on task. Notice a couple things. Notice there are no 60s, but we still put a number 6 in our stem. Notice that we evenly space out the leaves as they move across the page. Okay? One leaf, the next leaf, and so on. Okay? A couple things to notice. Notice that there's a title. We always want a title when we're making data displays that gives us some information about what's going on. All right, we're going to look at another one just for reference. Donation to charity in dollars. And again, this would be read, somebody gave $48 to charity. Somebody gave $22. Somebody gave $25. Somebody gave 10, 10, 10, 10. All right, actually 4 people gave $10. All right. And up here with a 0, there is no tens digit. Where we've got 1, 1, 2, 5. Okay. Giving less than $10. All right, so that's how they're read. What are stem and leaf plots good for? They're a good way to organize and display data because they show 2 things, right? 2 things that we're often asking about data. Where's the center, right? Where is the center of the data? And how is the data dispersed or distributed? So if we were to compare the 2 stem and leaf plots that we've looked at already, I would say that this one, donations to charity, is heavily concentrated near the top, right? Where the numbers are smaller. All right, the center of my data is closer to 0 than it is to 40. If we look back at the other one, right, my data is more equally distributed. The center of the data has the biggest number of individuals. And then as we get to the edges, we've got fewer, right? So that's how it's spread out. Okay. So that's one thing that we're looking at when we're looking at stem and leaf plots. How does the data fit in a big picture? The other things that are easy to find are what's the maximum? What's the minimum? All right, maximum, biggest number in the set, it's 90. What's the minimum? 41. Okay, they're easy to find when we organize data in this way. Even what's the actual middle number in the set, the median, it's pretty easy to find, right? Because you could just count in three numbers, 4, 5, 6, 4, 5, 6. All right, the middle of my set, 79, right? The median's pretty easy to find. Okay. In order for the median to be easy to find, something else that I should point out with your stem and leaf plot is your stem needs to go in order. Okay, you can choose from biggest to smallest or from smallest to biggest. Your leaves need to go in the same order. All right. If you are arranging your stem smallest to largest, you also need to arrange your leaves smallest to largest. So 1, 1, 2, 5, 5, 10, 10, 10, 10, 14, 15. Okay. My leaves are arranged in order from smallest to largest. That way, I can look through the list, left to right, and top to bottom, and I'm getting my data elements in order. Okay? If we look back at our other one, when I arrange my stem from biggest to smallest, I also have to arrange my leaves from biggest to smallest. So looking at the 80s row, right? 87, 86, 84, 83, 79, 79, 79, 73. Okay. So if you can't read left to right, top to bottom, your stem and leaf plot in order, something's wrong with it. Okay. Now, that's reading. A couple of different things that you can take out of a stem and leaf plot. What about creating a stem and leaf plot? Daphne takes care of snakes in Alpha Reptile House. On September 4th of each year, she measures them. Most recently, she measured the following lengths in inches, right? And you got a bunch of numbers. Arrange this data into a stem and leaf plot. Typically, when I'm doing a stem and leaf plot, I do it in 2 stages, right? I do a rough draft and then a finalized version. Okay, so the way that I do it, first I'm going to scan through my numbers, see if I can find the biggest and the smallest number. It looks like we have single digit numbers, and the biggest number might be 54. I'm going to look 57. Okay, so my largest value is 57. I like to put the largest numbers up top and then count down 5, 4, 3, 2, 1, 0. That'll be my rough draft stem. Then what I do is I'll just look through and put my numbers into their appropriate rows. So 57, 54, 14, 31, 29, 15, 36, 37, 28, 36 again, 12, 21, 36, 8, 19, 11. Okay? And I can double check. I have 2, 4, 6, 8, 10, 12, 14, 16 leaves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data elements. Okay? Now, why did I say it's a rough draft? Well, notice my leaves aren't in order. I also don't have a title, which is a problem. So I get a basic picture for where the leaves should be, then finalized version. Let me give it a title, Snakes in Inches. And put my stem again, 5, 4, 3, 2, 1, 0. And now I'm going to make sure that my leaves are in order. Since I'm going from biggest to smallest in the stem, I'll go from biggest to smallest on my leaves. So 7, 4 was already okay. Let me leave some space. 40s. There are no 40s. 30s. 7, 6, 6, 6, 1. 7, 6, 6, 6, 1. Okay, notice I'm trying to keep my numbers evenly spaced out. 20s, 9, 8, 1 was fine. Already in order. 10s, 19, 15, 14. 19, 15, 14, 12, 11. And lastly, my 8. That's a completed stem and leaf plot. All right, let me point out one more or two more things before I close this out. This guy right here, number 1, I would take points off if you made this. Why? Because it's missing a title. Right? I don't have any information about what this stem and leaf plot is about. All right, number 2, this looks weirder than the regular stem and leaf plots. All right, there's numbers over here as well as over here. This is called a double stem and leaf plot. And it's usually used if you're trying to compare two different things. For example, how are my 9th grade students doing in class compared to how my 10th grade students are doing, or something like that. So you would put one set of data to the right, you would put the other set to the left. The stem is still in the center, so we still always start reading our numbers from the center. 98, 98, 92, okay? On the other side, 96, 93, 91, right? See that? So when you're doing a stem and leaf plot, one of your domains, one of your areas, you're kind of reading backwards. You're reading from right to left, okay? Because we're always going to start with the stem. But what this lets you do is compare two different sets of things, okay? For example, who's doing better? Well, as a whole, this group seems to have higher scores, right? The center of their set is farther toward the top. They don't have too many low scores. All right, now this group over here, if I want to make a case for them doing better, they do have more students in the 90s, right? But it drops quickly after that. Okay, so back-to-back stem and leaf, double stem and leaf plot, got to be aware of it if you ever see one. Last thing, I'll throw one more data term up there that I'm sure you already know, mode. All right, that's the thing that shows up most often. In my data set on the right, the mode would be 72. And you can see this is another thing that is very easy to find when you arrange your data into stem and leaf plots. Okay, if I ask for the mode on the left-hand side, you actually have more than one because there's no individual one that stands out. You've got 90, 59, and 40 all share the status of mode on the left. So at this point, you should be able to create stem and leaf plots, read stem and leaf plots, and find key data elements within them.